In our last lesson, we found out that Midjourney likely uses the same type of machine learning models as other AI image generators like Stable Diffusion. This is called the latent diffusion model. It has two big parts, clip and unit. You got to know that this latent diffusion model is the brain behind AI image generators. This brain, called a neural network, learns from its mistakes. It uses lots of data from the internet to learn. Words get changed into tokens, and pictures are turned into special codes or vectors that show what's in them. You learned about the first big part of the latent diffusion model, which is called CLIP, and which knows how to match words with pictures. In this lesson, we talk about the second big part, the unit model, and see how your words generate a picture using all these parts. So let's delve deeper into the latent diffusion model. This technology revolves around the idea of using latent spaces. Think of these spaces like a compressed version of data where we squeeze a large amount of information into a smaller package, retaining only the essential bits. This process is somewhat like reducing the size of a big photo, but ensuring the main picture is still clear. A crucial player in this process is the unit architecture. Unit is like a master artist specifically designed to work with images. It's so named because its structure resembles the letter U. It's trained for reducing images down to their most essential attributes and then expanding them back to their full form. To put it simply, imagine we are teaching a computer to recognize and sort pictures. This computer or model studies different parts of a picture, like its shapes, edges, and angles. When it learns from a picture, it first makes the picture smaller and simpler. After it's done learning, the computer can make the picture look normal again. This process of making things simpler helps the computer focus on the most important part of many pictures. Because of this, the computer can easily tell the difference between different objects in the pictures. Once we have this compressed data, we introduce the concept of diffusion models. These models play a game of adding and then removing noise to generate an image based on textual descriptions. Now imagine a clear photo of a cat. First, they add noise or random speckles to this photo multiple times until the whole photo looks all messy and noisy. That's the forward diffusion process. Then comes the backward diffusion step. Here, they remove the noise bit by bit, aiming to get back to the clear cat photo. For this cleaning job, they train and use a special model you already heard about, called UNet. UNet looks at the noisy photo, figures out how noisy it is, and starts cleaning it up. It does this by simplifying the photo, working on the important part, and then expanding it back to the full picture. Imagine zooming into a puzzle, working on a few pieces, then zooming back out to complete it. The main goal of this is to practice on noisy photos so much that they get really good at cleaning and understanding pictures. Now, here is where things get even more fascinating. We can integrate text into this process. Inserting the text in this diffusion model is done by embedding using language transformer neural networks, which means that numbers, or tokens to be precise, are added to the words. This is achieved using the CLIP model, which you might already be familiar with. And then this representation of the text is added to the input, in this case the image in the unit. It goes through each layer of the unit neural network and transforms together with the image. This is done from the first temporal iteration, and the same text is added to each following iteration after the first estimation of the noise. We could say that the text serves as a guideline for generating the image starting from the first iteration, where there is a complete noise, and then further down to the entire iterative method. Imagine starting with a rough sketch and slowly refining it until you have a detailed drawing. Humans begin with a blank canvas, but machines start with a noisy picture. This is because the neural networks are designed to clear away noise and adjust pixels like a puzzle to create an image. Every time you generate a picture, you will get a random seed number or starting point for the noise. If you use the same number, text prompt, and version of Midjourney, you should get the same picture again. We'll talk more about what this seed number is and how to use it for making consistent and similar pictures later in the course. There is also a cheat code involved called the classifier free diffusion guidance, and it's a key trick that makes image generation work really well. Think of it like a secret tip shared by Google a while ago. During the image generation process, the machine focuses more on the given text. Instead of making any image, it tries to match the text details. But with this cheat code, there is a twist. Sometimes during learning, the machine intentionally ignores the text to see how it does on its own. For the latent diffusion model, it ignores the text about 10% of the time. Given the complex design of the latent diffusion model, it can create images entirely from the ground up using a text prompt. This enables users to specify which components should appear or be omitted in the final image. Additionally, users can introduce new elements to a pre-existing image using a text prompt and in-painting. Users can also generate an image from another image or upscale an image. But what truly sets the latent diffusion apart is its efficiency, because instead of using the pixel space and millions of parameters and neurons inside a neural network, like previous models, it uses the latent space. While many models would take ages and consume a lot of computational power, stable diffusion with its latent diffusion model gets the job done quickly and efficiently. It's nimble enough to work on a regular computer, but powerful enough to create detailed images, whether generated from scratch or by modifying an existing one. It's important to mention that these new ideas didn't just emerge overnight. They evolved over time, building on past ideas from fields such as computer vision, language processing, and even medicine. In conclusion, we can assume that Midjourney and other AI image generators made some fine-tunings to a pre-trained model, which is very likely the latent diffusion model. When it comes to input, Midjourney will use your main concept and add elements of its own to generate the stunning images. In this process, some of your input keywords may get ignored during the generation, as the tool will create its own iterations with relevant colors, lighting, and other elements. If you wish to replicate these images on Stable Diffusion, you will have to provide a longer prompt with more details than what you may have entered on Midjourney. Generative models are developed and improved, we can freely say, on a weekly basis, and it will be very interesting to keep track of their future progress. But there are some limitations when you use Midjourney. Some inputs aren't allowed because they get checked first. There is a limit to how much the model has learned. Even though it learned from a lot of data, the training had to stop at some point. It's not perfect. It might make mistakes with things like hands or text in images. Some ethical concerns have arisen due to biases. After training the neural network, you get a basic model that can generate images, but it's not perfect for specific projects. AI image generator companies can make it better by fine-tuning it. Fine-tuning helps the model work better for certain art styles. So the final latent diffusion model is improved and polished for its purpose. For example, to create more realistic images or to create better pixel art in game development. Congratulations, you've gained a good understanding and now you have a basic idea of how this technology functions in the background. To wrap it up, we looked at how AI image generators like Midjourney work. They use a special model called latent diffusion model that has two parts, clip and unit. The main trick is that it takes big information and makes it small and simple. Think of unit as a painter. It looks at the main parts of a picture and then draws it again. Some models add messiness to pictures, then clean it up. This helps the machine understand pictures better. Now, this latent diffusion model can also use words with pictures. These words help guide the latent diffusion model. However, a technique called classifier-free diffusion guidance allows the model to sometimes ignore the text, enhancing its learning. The model is quick and doesn't use a lot of computer power. In the end, tools like Midjourney might use pre-trained models like the latent diffusion model and make them better. And these AI tools are getting better, but they are not perfect and have limitations.